Hi students, welcome to my channel. In this video, we are going to learn basic properties of electric charges. Can you guess some properties? Yes, you are guessing so right. Follow this video and check your answers, okay? There are three main basic properties for electric charges. They are electric charge is a scalar quantity, conservation of electric charges, quantization of electric charges. Let me teach you one by one. First is electric charge is a scalar quantity. To explain, I recollect the properties of subatomic particles, protons, electrons and neutrons. The subatomic particles, you know that the protons have positive charge with mass 1.67 into 10 power minus 27 kg and electrons are negative charge with mass 9.1 into 10 power minus 31 kg and neutrons are of neutral charge with mass 1.67 into 10 power minus 27 kg. The subatomic particles possessing charge and mass are fundamental, inherent and intrinsic property of particles. Here the words inherent, intrinsic means properties belonging to its internal nature and exist permanently. That is, the properties belonging to its internal nature and exist permanently. Here, you know that mass has only magnitude and direction is not considered for mass. So, mass is a scalar quantity and we consider only the numerical values. To show that charge is a scalar quantity, we go for addition of charges. Consider an object with n number of charges. Charges will be both positive and negative and distributed on different parts of the object. The total charge on an object is equal to the algebraic sum of all the charges with proper sign. That is, total charge is equal to Q1 plus Q2 plus Q3 plus and so on up to Qn. If we add the charges plus 5Q minus 8Q plus 15Q, what you get as total is plus 12Q. Here plus 12 gives the magnitude, that is the numerical value. That is, the total charge will be a numerical value and it does not represent any direction. Only magnitude, that is numerical value is considered. So that electric charge is a scalar quantity. Students, in the 19th and 20th century, many experiments were performed to understand the nature of electric charges. The SI unit of charge is coulomb. I hope you all will be clear in the first property, and now let's move to the second property. Second property is conservation of charges. Benjamin Franklin was the first person to use the terms positive and negative charge. He explained, when an object is rubbed with another object, charges are not generated by rubbing. Then what is happening? Charges are transferred from one object to the other. Here, initially, before rubbing, both objects are electrically neutral. To explain this, here is our familiar example, glass rod rubbed on silk cloth. When a glass rod is rubbed on silk cloth, negative charges are transferred from glass rod to silk. The glass rod loses negative charges and becomes positively charged, and silk cloth gains negative charges and becomes negatively charged. All these studies gives conservation of charges as the total electric charge in the universe is a constant, that is conserved. In any physical process, the net change in charge will always be zero, and the charges are neither created nor destroyed. Charges can only be transferred from one object to other. Okay, now let us move on to the third property. Third is quantization of electric charge. The smallest amount of charge is the fundamental unit of charge. And two, this smallest amount of charge is the magnitude of charge carried by an electron or proton. Okay, the smallest amount of charge is the fundamental unit of charge, and this smallest amount of charge is the magnitude of charge carried by electron or proton. The smallest amount of charge or fundamental unit of charge is represented by E, and its value is 1.6 into 10 power minus 19 coulomb. The charge less than this amount cannot exist freely. The charge on negatively charged electrons are denoted by minus E. The charge on positively charged protons are denoted by plus E. Are transferred, what happens is some numbers of fundamental unit of charge E is transferred, isn't it? Are you clear here? When charges are transferred, some numbers of fundamental unit of charge E is transferred. Let us denote some number by n. And you all know that n is an integer, and n takes values from 0 plus 1 to plus infinity and minus 1 to minus infinity. The n number can be written as integral multiple, and integral multiple of E, that is NE, gives the charge on any object. Therefore, the quantization of charge means the amount of charge Q on an object is equal to integral multiple of fundamental unit of charge E. That is Q is equal to NE, where n is an integer. Robert Millikan found the value of E to be 1.6 into 10 power minus 19 coulomb. So the charge of electron is minus 1.6 into 10 power minus 19 coulomb, and the charge of proton is plus 1.6 into 10 power minus 19 coulomb. Okay students, now let us learn about the quantization of charges in microscopic level and macroscopic level. In microscopic level, the number of charges transferred is very small, that is in the order of few tens or hundreds of each, and can be counted. So quantization plays an important role in microscopic level. Now let us see what happens in macroscopic level. When a glass rod is rubbed with silk cloth, the number of charges transferred is very large, in the order of 10 power 10, which is not countable, isn't it? So charge quantization is not appreciable in macroscopic level. Okay students, I hope that you all listen to my words. After listening to this topic, you take your note and recollect the points. Do it as a task, and it will be very helpful in your studies. Thank you.